This is Mrs. Zappia with Lesson 21 and 22, Surface Area, from Module 3. Student outcomes from this lesson. Students find the surface area of three-dimensional objects, whose surface area is composed of triangles and quadrilaterals. They use polyhedron nets to understand that surface area is simply the sum of the area of the lateral faces and the area of the bases. The essential question for this lesson: how do you find the surface area of three-dimensional objects whose surface area is composed of triangles and quadrilaterals? There are some key terms to go over for this unit. A right prism can be described as a solid. So let's take a look at a right prism. The solid is three-dimensional. It has two end faces, and these are called the bases. So in this figure, it is the blue top and bottom that are the bases. They are the exact copies of each other, and the rectangular faces, so this is a rectangular face, that join the corresponding edges of the bases, and these are called the lateral faces. So again, the base is the opposite sides that are the top and the bottom in this case. They are exact copies of each other. They're parallel and congruent. The rectangular faces connect the bases at the edges. A right rectangular prism is a solid, three-dimensional object which has 6 faces that are rectangles. A right triangular prism is a prism that has 2 congruent right triangular bases, one directly above the other, and has its lateral faces as rectangles. So this is a prism. It has 2 congruent right triangular bases, and one is directly above the other, and the lateral faces are rectangles. So we have a rectangle on the left, a rectangle on the right, and a rectangle in the front, and those are called the lateral faces. A cube is a right rectangular prism of all of whose edges are equal length. A surface. The surface of a prism is the union of all of its faces, the base faces and the lateral faces. A net is a two-dimensional diagram of the surface of a prism. So this is the example of the net. It is two-dimensional, so it has length and width, and it covers the surface of the prism, and you could actually wrap it around the three-dimensional figure. Then we'll skip this opening exercise, and we're going to go to example 1, the lateral area of a right prism. A right triangular prism, a right rectangular prism, and a right pentagonal prism are pictured below, and all have equal lengths of height. The height is the segment that connects the bases. So this one is a triangular prism because its base is a triangle. This is a rectangular prism because the base is a rectangle. This one is a pentagonal prism because the base is a pentagon, a 5-sided polygon. Notice that on all 3 figures, the lateral faces are the faces or the quadrilaterals that are not the bases. Notice that they are quadrilaterals. That means that they have 4 sides, and they are rectangles. Write an expression that represents the lateral area of the right triangular prism as the sum of the area of its lateral faces. We want to describe the lateral area. So let's go first over what the lateral area is. The lateral area is made up of the rectangular faces. And this excludes the bases. So first we're going to do the right triangular prism. And the right triangular prism is right over here. And it's a right triangular prism because the base is made of a right triangle. And what makes it a prism is that the top and bottom are parallel and congruent to each other and connected by the height. So we want to describe the lateral area as the sum of its lateral faces. So the lateral faces are rectangles. So let's start with a strategy. We'll call LA the lateral area. And we're going to find the area of the first rectangle on the left. Then we'll find the area of the rectangle, we'll call that number 2, on the right. And finally, we'll find the area of rectangle 3 in the front. So we'll call that the area of rectangle 1 plus the area of rectangle 2 plus the area of rectangle 3. So area of rectangle 1. We know that the area of a rectangle is length times width. And here we have a width of A and a length of H. And we can also think of that as base times height. So the area of rectangle 1 is A times H. And the area of rectangle 2, and that has B times H as its dimensions. And the area of rectangle 3, and that is C times H. So that describes the lateral area of the triangular prism. It's the A times H plus B times H plus C times H. Next, write an expression that represents the lateral area of the right rectangular prism as the sum of its areas of its lateral faces. So again, the lateral area is the area of the faces excluding the bases. We're going to write that as a sum of the area of the lateral faces. So the lateral area of the faces, we've got a rectangle on the left which is congruent to the rectangle on the right. So we'll call this rectangle 1, and we'll need 2 of those. So 2 times the area of rectangle 1. And then we also have the front rectangle, which is congruent to the back rectangle. So we have 2 of those. So we'll call that rectangle 2. And we want 2 of the areas in the size of rectangle 2. Then we know that those are rectangles. So we have the dimensions of the rectangle on the left, that is the height times B. Again, that is the height times B. So we have height times B, and we have 2 of those. So 2 times the height times B plus 2 of rectangle 2, and the dimensions of rectangle 2 are A times the height. So 2 times A times the height. And that's going to give us the lateral area of the right rectangular prism. Next, write an expression that represents the lateral area of the right pentagonal prism as the sum of the areas of its lateral faces. The lateral faces are the faces that exclude the bases. A right pentagonal prism, and it is called a pentagonal prism because the shape of the base is a pentagon. And we'll notice that each of these sides is a different length because they're a different variable. So this one, side A, has a different length than side E. So for the pentagonal prism, we have, let's call rectangle 1 in the front. And then we'll call the one on the left, this is rectangle 2. Then this will be rectangle 3, rectangle 4, and rectangle 5. So those are all of the faces. Then the lateral area is the sum of all of those faces. So we'll have the area of rectangle 1 plus the area of rectangle 2 plus the area of rectangle 3 plus the area of rectangle 4 plus the area of rectangle 5. Then let's take a look at the area of rectangle 1. Rectangle 1 has dimensions of A times H. Rectangle 2 has dimensions of B times H. Rectangle 3 has dimensions of C times H. Rectangle 4 has dimensions of D times H. And rectangle 5 has dimensions of E times H. And that is the sum of the area of the lateral faces of the right pentagonal prism. Next, rewrite each expression in factored form using the distributive property and the height of each lateral face. So our first problem was the lateral area of the triangular prism, and it had a lateral area of AH plus BH plus CH. In factored form, it has a common factor of H. If we factor out the H, we have A plus B plus C. So the factored form is H times the quantity A plus B plus C. The other figure, the right rectangular prism, the lateral area was 2 times the base times the height plus 2 times the base times the height. So we can factor out the height. And that leaves us with 2b plus 2b. And actually, I think that needs to be changed to a. There we go. 2 times b times h plus 2 times a times h. So we factor out the h, and that gives us the height times the quantity, 2b plus 2a. Then we had the right pentagonal prism, and that one had a lateral area of AH plus BH plus CH plus DH plus EH. And the common factor is H. So we can factor that out, and that will leave us with A plus B plus C plus D plus E. So the factored form is H times the quantity A plus B plus C plus D plus E. What do these parentheses in each case represent with respect to the right prisms? So A plus B plus C. Let's take a look at our prism. And I'll erase all of this so that we can look a little closer. They're asking, what does A plus B plus C represent? What does A plus B times 2 represent? What does A plus B plus C plus D plus E represent? All of those represent the perimeter of the base. This represents the perimeter of the triangular base. 2A plus 2B represents the perimeter of the rectangular base. And adding all the lengths of the 5 sides represents the perimeter of the pentagonal base. How can we generalize the lateral area of a right prism into a formula that applies to right prisms? Okay, so we're looking for the formula for the lateral area of right prisms. And we'll call that LA. The lateral area of a right prism can be found by multiplying the height times the perimeter. The height times the perimeter, where capital P represents the perimeter of the base. Again, the lateral area is the height times the perimeter of the base. The height times the perimeter of the base. The height times the perimeter of the base. The lateral height of right prisms can be found by multiplying the height times the perimeter of the base. Let's go ahead and answer this last question here on the previous page, 163. What value appears often in each expression and why? So the value that appeared often was the value of h. And so that's why we factored out the h. All right, so we're going to go ahead now to lesson 22. The essential question is, how do you find the surface area of a pyramid? What are some strategies for finding the surface area of solids? On page 171, the pyramid in the picture has a square base, and its lateral faces are triangles that are exact copies of one another. Find the surface area of the pyramid. So we're looking for the surface area. Let's define what that is. The surface area is the sum of the area of each face and base. The surface area is the sum of the area of each face and base. And if we took a look at what a pyramid is made of a base, and then it has lateral faces that come to one vertex at the top. And in this case, the base is a square. So all of the lengths of this side are the same. Since the lengths of the sides are the same, that would make the area of each face the same. So the area of this face is the same as the area of this face because they have the same base and height. So all four sides will have the same area. Then if you think, what is this made of? This is made of a square base, and actually it's a square, so I need to adjust those sides there. All four sides are the same length. And then if we made a net of this, then all of these faces would have the same size as well. And then we look at how do you find the area of the base and how do you find the area of each face. So our strategy for surface area is going to be finding the area of the base and then adding to it the area of the triangles, and there are 4 of them. So we'll write that as 4 times the area of the triangles. And we know that the area of the base, we know that that is a square, and we know that the area of the lateral faces are triangles. So the formula for a square is length times width, or side squared. And we know the area of a triangle is 1/2 times base times height, and there are 4 of them. And the side squared, we've got 6, so we've got 6 squared plus 4 times the quantity, 1/2 times. And then let's take a look at the base and the height of the triangle. The base and the height of the triangle are perpendicular to each other. So we have a base of 6 and a height of 7. So 6 squared is 6 times 6, which is 36. And we have 4 times the area of a triangle. Half of 6 is 3. 3 times 7 is 21. 4 times 21 is 84. And 36 plus 84 is 120. So our surface area of the entire pyramid is 120 square centimeters. Notice that it is not cubed. We are not filling it, we are covering the outside of it. In this lesson, you have learned the surface area of a square pyramid is the sum of the lateral area and the area of the base, where the lateral area is 4 times the area of the triangle, and the capital B is the area of the base. The lateral area of a right rectangular prism is the height of the prism multiplied by the perimeter of the base. So you find the perimeter of the base, you multiply it by the height, and that is the lateral area, which is the area of the 4 sides of the prism. Finally, the surface area of the right rectangular prism. And when you're doing the surface area of the right rectangular prism, remember that you are doing the lateral area, which is all 4 sides, plus 2 bases. So the area of the base times 2. The surface area of the right rectangular prism is the sum of the lateral area and the area of both bases.